Hi, good evening. Today we are going to discuss another section of differential equation, right? So last class we seen how to solve a higher order linear differential equation. What we have seen, first we have to find a complementary function. Different method for finding complementary function we seen, and we were in the discussion of particular integral finding, right? Then after finding complementary function and particular integral, we add both. That is the final differential equation of the solution, right? Now this particular integral, what we see in different types of function executing on the right hand side of a differential equation, that time different method we seen. Alright. Now today, if right hand side coming the function in the form of x raised to n, right? See, q is equal to x raised to n coming. That time how we solve the differential equation. So let me express, suppose if you have a differential equation d square y by dx square, say plus 2 dy by dx plus y equal to some x raised to n, right? So the right hand side should be in the form x raised to n, right? That time what you have to do, you write the differential equation as d square plus 2d plus 1 into y equal to x raised to n, alright? Now you represent this as y, the particular integral solution, that is y is equal to x raised to n divided by this, you can write as d plus 1 the whole square, right? D plus 1 the whole square. Now what you write? Now this you write in this form, then y is equal to, you are writing x raised to n into, this you can write as 1 plus d whole raised to minus 2, right? Alright. Now 1 plus d whole raised to minus 2, you can represent in terms using binomial theorem. What you can write? 1 plus x whole raised to n, that is 1 plus, right, using by 1 plus nx, that is minus 2d plus, right, then n into n minus 1, then minus 2 into minus 3 into 1 into 2, that is 2 factorial into x raised to, that means d raised to d square, alright. Alright. So like this we follow. Okay, 1 plus nx, right? Now here x raised to n. So now this expand like this. Now x raised to n, the solution is multiply x raised to n into plus minus 2 into differential of x raised to n, that is nx raised to n minus 1, and then differential of second derivative of x raised to n. That expansion complete means that is the final solution. Understood? So one problem we do, then you will get a clear picture, right? So here we have one question. See, the differential equation is, so here given what d square y by dx square minus 4 dy by dx plus 3y into x square. So what is the first solution? First we find complementary function. What auxiliary equation solve? M square minus 4m plus 3 is equal to 0. This is m minus 1 into m minus 3 equal to 0. That is m is equal to 1, m is equal to 3. Right. Then what is complementary function? Say this is m1, this is m2. Then what is the, if m1, m2, by solving auxiliary equation, if m1 and m2 are different, what is the method? You can write a solution as c1 e raised to m1x, that is 1x, plus c2 e raised to m2x, that is what? 3x. Now particular integral solving, if it is this side is x raised to n format, what you have to write? X square divided by, this you can write as what? D square minus 4d plus 3, d square minus 4d plus 3, right? Now this you can write as, what you can write? X square divided by, you can write this as 3 you can take out, then what? 1 minus 4 by 3 d, am I right, plus d square by 3, right. Now this you can write as x square by 3 into 1 minus of, right, 4 by 3 d minus d square by 3 all raised to minus 1. This term I have taken to denominator, right, sorry, denominator taken to numerator, then this power become minus 1, and here I taken minus common. Now this is 1 plus x all raised to n format, then this I can write as x square by 3 into, right, 1, right, plus nx, that is n is minus 1 into x is what, 4 by 3d, right, minus of, see this is 1 plus x format, then minus of 4 by 3d minus d square by 3, right. Then what is this, that is x square by 3 into, so minus minus plus, then 1 plus 4 by 3 d minus d square by 3, 4 by 3 d minus d square by 3. Now x square by 3, this is equal to, am I right, this is equal to x square by 3, right, x square by 3 plus 4 by 3 into x square by 3, what, 4 by 3 I taken out, then 4 by 9, right, 4 by 9, am I right, this is 4 by 9 into differential of x square, that is 2x, minus, here again 1 by 9 into, am I right, 1 by 9 into double derivative of x square, what, that is 2 only, right. Now what is the final particular integral? So we can add both. Then what is the solution? Final solution is sum of complementary function and a particular integral. Am I right? What is complementary function? This one, that is c1 e raised to x plus c2 e raised to 3x plus what is particular integral? X square by 3, right, x square by 3 plus 8 by 9x, minus, this is 2 by 9, right, plus c. So this is the final solution, alright. So like this we can solve it if x raised to power coming on the right side, alright. Now let us go to another option, right. If, this is very important, look here, suppose we seen what we do when e raised to ax come on the right side, x raised to n come on the right side, cos x come on the right side. So different method we seen, right. So cos x, x raised to n or e raised to x, these are all single function. Now look here, if the function, suppose a differential equation d square y by dx square plus say 2 dy by dx plus y equal to, see one mixed function, one is e raised to say e raised to ax and other is another function v of x. This v of x may be, see this v of x may be, maybe this is v of x may be sin x or x square, both possible. E raised to ax is the one function and in the mixed function, second function coming as what, second function coming as x raised to n or sin trigonometric function. That time how we solve, alright. So that we are looking, okay. So how we solve such kind of differential equation, that only we are focusing, alright. So now let us go to first, the method is we can do by a problem. If suppose e raised to ax, suppose here you find complementary function first. So y is equal to complementary function plus and particular integral, alright. Complementary function plus particular integral. Complementary function by solving auxiliary equation, you know how to solve it. To find right, to find the particular integral, what we do, we write this as, right, suppose this v of x is say some x square, right, then suppose this is d square plus 2d plus 1. Now we have e raised to ax x square. Alright, understood? Now first you have to do here, you have to add this a here, the coefficient of this x, e power x, right? This x power is a, that you have to add here first. D plus a the whole square plus 2 into d plus a, right? Then you can take e raised to ax out. Once e raised to ax getting out, you know how to do x raised to n after that, right? So let us go to one example first, then we come to how we solve, suppose e raised to ax into some sin x or cos x come. Alright, alright. Now let us see. See here the question is, here see d square minus 2d plus 1y is equal to x square e raised to 3x. First we find a complementary function. What is complementary function? Complementary function is by solving the auxiliary equation, m square minus 2m plus 1 is equal to 0, that is m minus 1 the whole square is equal to 0, then m is equal to 1 1. Alright. So you can solve m1 means both solutions are equal, means how we write c1 x plus c2 into e raised to m1x. m1 m2 is equal to m only, that is 1x. This is complementary function. That is, now you go to complementary function. Now complementary function plus particular integral. Now particular integral we need to find, right? Particular integral finding, what is the method I told? Y you can write as x square e raised to 3x divided by the function d square minus 2d plus 1 into y. Sorry, this y not equal to, this y need not write. Y we keep here and write like this. Alright. Now what is this? This is equal to our particular integral. Right? Now what I told you, first e raised to 3x you take out, then that time all the d you add with 3, then e raised to 3x I taken out, x square I am keeping here, now d plus 3 the whole square come here, minus 2 into d plus 3, all d added with this coefficient 3, right, plus 1. Now e raised to 3x I taken out, am I right? Then x square divided by, you expand this, see d plus 3 whole square what? D square plus 6d plus 9 minus 2d minus 6 plus 1, right? Now, alright, 6 only. Now 6d 2d, then d square plus 6d minus 2d what? That is 4d, and 9 minus 6 what? 3, 3 plus 1 what? 4. This is what? D minus 2 the whole square, right? Alright, this is d minus 2 the whole square, right? This you can write as d minus 2 the whole square. D minus 2 the whole square I can write as 4 into 1 minus d the whole square. 2 I am taking out, right? 2 I am taking out, alright? Then 4 into, so I can write as 4 into 1 minus d the whole square. Taking 2 out and come out of the square, then 4, this is d minus, then you can write as, you are taking, then d by 2 come here, right? Am I right? If you 2 take out, there is no 2 here, then d by 2, here 1. Then d by 2 minus 1 I can write, d by 2 minus 1 whole square I can write as 1 minus d by 2 the whole square, right? Then 1 minus d by 2 the whole square. Then what? E raised to 3x into x square, right? X square into this 4 I am taking out, this I can write as 1 minus d by 2, right, all raised to minus 2. Am I right? Now you expand this, that is e raised to 3x by 4 into, am I right? This 1 minus x square into, here 1 plus nx, that is 1 plus minus 2 into minus d by 2 what, that is 1 plus d, and next term is plus n into n minus 1, that is minus 2 into minus 3 divided by 1 into 2 into d by 2 the whole square, that is d square by 4. Alright. Then what is the next term? Plus etc. Up to d square by 4 only we are writing. Why? Because second derivative of x square will be, that is 2. Constant came now, next proceedings not happen. Right. Then e raised to 3x by 4 into, now you can multiply what, x square plus differential of x square what, 2x. Alright. This 2 cancel, minus 3d square, then plus 3 by 4 into d square, double differential of x square what, 2. Then this 2 cancel, then 3 by 2. Now this is the particular integral, right? So this plus and what is our complementary function? This, that is the net solution. Alright? Understood? So this way you can find. Alright? Now let us go to, instead of e raised to 3x, e raised to 3x and a function x square. Now e raised to 3x and another trigonometric function sin x or cos x coming. That time how we solve? That is the next step. Alright? Alright. So let us directly go to the question. See, q of x in the form of x raised to n sin x or cos x. In this case what you write, you know, see, suppose your function is, suppose let me write like this. Suppose one function is given like this, d square minus 2d plus 1 into y is equal to e raised to x sin x. If e raised to x sin x means you have to write sin x as, for example, what is e raised to ix? Sin x plus, this is I is complex number, sin x plus, sorry, cos x plus I sin x, right? So we write like that, right? So we can, then sin x is the coefficient of or imaginary part of this e raised to ix, right? Sin x is the imaginary part of e raised to ix, cos x is the real part of this e raised to ix. That formula we use. What we write? Y is equal to imaginary part of what, d square by e raised to ix into e raised to x, alright, divided by d square minus 2d plus 1. So like that we return and then we solve. This is the method we are going to practice here, right? So let us see what happened. One problem we do, if it is cos x, here cos x come means what you write? Real part of e raised to ix, you write. Real part of e raised to ix into, here e raised to x means you write e raised to x, alright? Then we solve. For example, let me see one question. See here, one question given, x sin x, right? So if it is x sin x also, you have to do the same, right? One function trigonometric, other function may be e raised to ax or any x raised to n format, we do the same. So first what we do means, see what is the auxiliary equation? M square minus 2m plus 1 equal to 0. By solving this m minus 1 the whole square is equal to 0, then m is equal to 1 1. Then what I can write is complementary function is equal to, we already seen complementary function finding before, that's why I am not spending much time on it. What I can say, c1x plus c2 into e raised to mx, m is what, 1x, this is complementary function, alright. Now we focus on particular integral. What is particular integral? Particular integral is what? So what I can write? See, this is sin x only. Then imaginary part of our function is x sin x. Then sin x I am writing e raised to ix. Actually e raised to ix expansion, its imaginary part only, what is sin x. So instead of sin x I am writing imaginary part of e raised to ix. Why? Because e raised to ix is equal to what? Cos x plus I sin x. Then imaginary part of e raised to ix what? That is sin x only. Understood? Then I can write it like this, and this I can write as d square minus 2d plus 1. Now what I am going to do? E raised to ix I am taking out. Particular integral is equal to e raised to ix I taken out. Imaginary part of, see, then I you have to add here. Once e raised to ax come out means either you add e raised to ax come means you add a. Like that e raised to ix come out means you have to add I. Alright. Then d plus I the whole square minus 2 into d plus I plus 1. Right. Now you can write what is d plus I the whole square? D square plus 2i plus I square. I square is minus 1 minus 2d minus 2i plus 1. Right. I square is minus 1. Then this cancel, and here minus 2i cancel. Then d square minus 2d. Right. Then what I write? Particular integral is equal to e raised to ix into imaginary part of x divided by, say, this is d square minus 2d. The entire function I can write as d square minus expansion is d square minus 2d. Alright. Now what I write? That I can write as, see, x and d square minus 2d. If x come, what we do? We can take a d out. Right. 2d you can take out. Right. So if you take e raised to ix into 1 by minus 2d you take out means you can write as, this is 1 plus d square divided by, can I write like this? 1 minus 2d I am taking, so I can write 1 minute. See, here minus I can write minus d square by 2. Alright, and function is x. Right. And the imaginary part is here, so you can put the imaginary part here. Right. Then e raised to ix into, this I can write as minus I am putting here, e raised to by 2 I am taking here, 1 by d I am putting here, then x into what I can write? This is 1 minus d square by 2, 1 minus d square by 2. Alright. All raised to minus 1. All raised to minus 1. Am I right? Yes. Now, see, look here. This you multiply. Then what? Then this is equal to e raised to ix divided by 2 into 1 by d into x minus double differential of x, what is 0? X minus 0. Now, look here. 1 by d means what? Differential inverse. Differential inverse what? Integration. That means I can write e raised to ix divided by 2 into integral x dx. Right. Then e raised to ix divided by 2 into x square by 2. Then x square e raised to ix divided by 4. Right. Its imaginary part. Here one imaginary part is here. Then imaginary part of this what? This only the solution. How we find imaginary part of this? So I am writing here x square e raised to ix divided by 4. Right. Its imaginary part is the particular integral. Then I am writing in a fresh area. See, imaginary part of okay, x square e raised to ix divided by 4. How we find this? That is imaginary part of x square e raised to ix. What is that? X square into, what is e raised to ix? Cos x plus I sin x divided by 4. Then imaginary part of x square cos x divided by 4 plus I into x square sin x divided by 4. Imaginary part of this means this part only, that is x square sin x divided by 4. This is the particular integral. Am I right? After getting particular integral, what is the complete solution? Complementary function already we solved c1 plus c1x plus c2, right, e raised to x already we solved, plus what is particular integral? X square sin x divided by 4. So this is the complete solution. Alright. So like this mixed functions we can solve, right? So I think this is all about this section. Yes, of course, this is all about this section. And in next class we discuss about exact differential equation, Euler-Cauchy differential equation, this kind of differential equation and all how we can solve, right? All right, thank you.